Hey guys, so I'm gonna try doing this live with my cell phone and not on a tripod. We'll see how that works. I would like to talk to you about the practice problems that you have. So the first one that I have here, you can kind of see it looks like a proton and an electron in a hydrogen atom. So that's the one I'll be looking at. Let me flip that around for you real quick so you can see that. This is the problem I'll be working on your practice, number one. Okay, so we see there that we have a proton and electron, and we have a distance between the two of them of 5.3 times 10 to the negative 11th meters. We want to know the magnitude and direction of the electrical force. So let's kind of talk about how we're going to do that real quick. All right, so, oh, hold on, my orientation's locked. Let me change that real quick so I can change my camera. Okay, so first thing that we always do is we kind of do our E, F, Q, and Q equals. Okay, so if I flip this around like this, you can kind of see that there. Notice I put my Q charges there of negative 1.6 E negative 9 and 1.6 E negative 9. They want to know what is the force that the proton is applying, or the field that the proton is on the electron. So we will use this charge for our Q. If you remember correctly, hold on, let me get me a marker. So if you remember correctly, we had an equation written down in our text, and I wrote it up on the board yesterday or a couple of days ago. The equation is going to be E is equal to Fe over Q. So it'll look something like that. Okay. So it wants me to rotate back this way. All right, that's fine. It'll look something like that. So you're going to use this information, but the problem is we don't know Fe. So to solve for that, Fe is equal to KQQ over R squared. So we'll actually be using this information. We'll take that and plug this into this equation up here, and that'll make one of these Q's go away, and one of these Q's go away. And so we'll actually get the bottom version of the equation for our E. Okay? And so then that means we will have the field will be equal to 8.9875 E9. And then we'll put our charge of 1.6 E9 negative 19, and we'll have our negative. And then we'll divide that by R squared, which in this case was 5.3 E negative 11 squared. Okay, so that's how you would solve for that first problem. Go ahead and fill that in, and then I will move on to looking at the next one. Don't forget that if it's a negative answer there, then that means that it would cause an attraction. It would mean that it would be going to the electron, so the negative particle here, with it. So that means that when we ask about the field, it would be going towards the electron. So that's what we would be looking at for there. All right, move the next one. And it does not like me going into that. The next one asks you about a thunderstorm, has an electric field of up to 3.19 times 10 to the 5th Newton coulombs. What's the magnitude of the electric force if the fundamental charge is this? So we have to take this guy. We basically have E now. So if we come here, we have E, and it said that E was 3.19 E to the 5th, and we know that Q is 1.6 E negative 19. We want to know what F is. So my equation is E equals F divided by Q. If I'm going to multiply both sides by Q, and that goes away, so then I'll have these two numbers multiplying by one another will give me the force. So 3.19E5 times 1.6 E negative 19 gives me F. And that's how you would do that second problem. Okay? I am going to now move in and look at the next one. It wants to know what is the electric force. So you're going to do the problem just like we did number 2. Number 3 is just like number 2. Now the next one says, what is the electric force on the proton in this field? So the difference is it says, what is the electric force on the electron? And what is the electric force on the proton in this field? So we'll both be looking at, you'll be looking at this information. Your answers will be the same. One will be positive and one will be negative. So it says an electric field is directed along the positive axis. What is the electric force on an electron in this field? Okay, and so we would say it is, if it would, you know, that force is either going to be negative or positive, whereas this guy would be, so this guy would be negative, meaning it goes towards it. This guy would be positive, meaning it goes away. And then you move down to part 2 of this. What's the magnitude of the field strength? Oh, I'm sorry, I have those mixed up. I apologize. Number 5 and 6 are two different problems. So we'll be looking at 5 and 6. 5 has an electron moving through an electric field, experiences an acceleration of, I want you to go ahead and not do 5 and 6 because I took those off of the online homework. What I would recommend you do is use the practice to help you do the online homework. If you have any questions, don't hesitate to ask me, email me, do whatever you need to do to get help. So that way we can make sure we get this online homework done. It's due Thursday. I'll give you time in class to work on it. But when you get the chance, you need to work on it. You have questions, don't hesitate to contact me. Thanks. Bye.